Welcome to Deep Sleep Physics. I hope you're doing well and that you're ready to find some peace tonight. It's a pleasure to be your guide through the mysteries of the dark. Sleep is not simply the absence of wakefulness. It is an active biological process, structured, cyclical, and deeply coordinated between brain and body. As evening deepens, signals begin to shift gradually. Light exposure decreases, and the brain responds through subtle chemical adjustments. Melatonin begins to rise in measured concentration, released from a small structure deep within the brain, responding to darkness rather than fatigue. This hormone does not force sleep, it signals timing, aligning internal rhythms with the turning of the planet. At the same time, core body temperature lowers slightly. Metabolic rate begins to soften. Heart rhythm becomes more regular. Breathing grows slower and deeper. The nervous system gradually transitions away from alert vigilance toward restorative balance. Inside the brain, electrical activity changes in pattern. During wakefulness, faster beta waves dominate, supporting attention and analysis. Yet as relaxation increases, slower alpha rhythms begin to appear. Gentle, synchronized oscillations associated with closed eyes and reduced sensory input. Sleep unfolds in stages rather than all at once. Consciousness does not disappear instantly. It recedes layer by layer. Sensory processing decreases. Internal awareness softens. Neural networks reorganize their timing. In the early phase of sleep, light transitional states emerge. Brain waves slow further into theta rhythms. Thoughts become fragmented, imagery brief and fluid. Muscles relax, though not completely. Awareness drifts without structure. As depth increases, slow wave activity begins to dominate. Large synchronized pulses traveling across the cortex, rising and falling in steady cadence. This stage supports physical restoration, immune regulation, and cellular repair. The body begins rebuilding what waking hours gradually consume. Yet sleep is not only biological maintenance, it is cognitive integration. Memory traces formed during the day are reactivated in compressed form, transferred from temporary storage toward long-term networks. Emotional intensity is recalibrated, experiences woven gently into broader narrative. Later in the cycle, REM sleep appears, a phase marked by rapid eye movement and distinct neural activation. The brain becomes highly active once again, though the body remains still. Dreaming emerges from coordinated internal simulation, blending memory, emotion, and imagination. Throughout the night, these stages repeat in rhythmic cycles. Light sleep, deep sleep, REM. Each phase contributing uniquely to stability, attention, mood, and resilience. Sleep is therefore not passive. It is architecture, structured timing governed by circadian rhythm, chemical signaling, and electrical synchronization. Brain and body aligned within the same biological cadence. And as awareness settles into this understanding, the process feels less mysterious and more rhythmic. A natural oscillation between activity and restoration. guided by internal clocks older than conscious thought, carrying the mind gently toward deeper quiet. As sleep deepens through the night, coordination between brain and body becomes increasingly synchronized. Systems that operated independently during the day now align within slower biological rhythm. Energy is conserved, restoration prioritized. During slow-wave sleep, the brain enters broad, synchronized oscillations. Neurons fire together, then pause together, creating large, sweeping waves across the cortex. These cycles allow cellular recovery, stabilizing electrical gradients that sustain communication during waking hours. At the same time, blood flow patterns subtly adjust. Regions heavily used throughout the day receive restorative support. Metabolic byproducts accumulated during prolonged wakefulness begin to clear through regulated circulation pathways, maintaining neural efficiency over time. Muscle tone decreases further, allowing connective tissue and microscopic fibers to repair. Growth hormone is released in greater concentration during early, deep sleep, supporting tissue restoration, immune regulation, and overall physiological balance. Breathing becomes steady and rhythmic. Heart variability increases slightly, reflecting adaptive parasympathetic dominance. This state signals recovery rather than vigilance, allowing cardiovascular systems to recalibrate without strain. Meanwhile, memory consolidation unfolds in structured phases. The hippocampus replays fragments of recent experience in compressed sequences, transferring patterns toward long-term cortical storage. Learning stabilizes quietly, without conscious rehearsal. Emotional regulation is also refined during sleep cycles. Neural circuits associated with stress and arousal gradually reduce in intensity, while regulatory networks strengthen, allowing emotional responses to feel more balanced upon waking. As the night progresses, REM phases lengthen. Brain activity becomes more variable, resembling wakefulness in certain regions, though motor systems remain inhibited, preventing physical movement. Dreams arise from coordinated activation between memory, imagination, and emotion. These alternating cycles between deep restoration and active integration repeat multiple times, each serving distinct biological functions, together forming the architecture of healthy sleep. Circadian timing continues guiding this progression. Internal clocks maintain alignment with environmental light cycles. Hormones fluctuate predictably, preparing the organism gradually for eventual awakening. Throughout this entire process, sleep remains structured rather than random. Every phase governed by coordinated electrical signaling, chemical balance, and evolutionary adaptation. The body rebuilds. The brain reorganizes. Systems recalibrate without effort. Beneath fading awareness, complex integration unfolds in quiet precision. And as these rhythms continue their measured repetition, the boundary between thought and physiology softens. Mind and body operating as a unified system, guided by slow, synchronized waves, carrying awareness gently toward deeper, restorative silence. As cycles continue through the night, REM sleep begins to occupy longer intervals. brain activity becomes vivid and dynamic. Electrical patterns shifting into faster frequencies, while the body remains profoundly still, protected by temporary muscular inhibition that prevents outward movement. During this phase, internal imagery becomes more elaborate. Networks associated with memory, emotion, and visual processing activate together. The brain simulates experience without external input, weaving fragments of the day into symbolic sequences. Dreams are not random constructions. They arise from structured neural interaction. The amygdala contributes emotional tone. Memory networks supply fragments of experience. Associative regions connect them into fluid narrative. Yet executive control remains reduced, allowing unusual combinations to form naturally. This altered balance supports emotional recalibration. Events charged with intensity during waking hours are revisited within safe internal simulation. Stress signals diminish gradually. Emotional responses soften through repeated processing across cycles. At the same time, autonomic systems fluctuate gently. Breathing may vary slightly. Heart rhythm shifts in subtle patterns, yet overall stability remains intact. The organism continues resting even as the brain becomes active internally. REM sleep also supports creativity and problem integration. Associations formed between distant memory networks strengthen quietly. Connections that might not emerge during focused waking thought arise within this fluid neural environment. Across the night, early cycles emphasize deeper, slow-wave restoration. Later cycles extend REM duration, ensuring both physical repair and cognitive integration receive adequate time within the structured rhythm. Circadian timing coordinates these proportions carefully. Hormonal signals adjust toward morning, preparing sensory systems for gradual reactivation, while REM episodes reach their longest span just before waking. Even during vivid dreaming, the brain remains governed by biological precision. Neurotransmitter balances shift predictably. Inhibitory signals maintain muscular stillness. Oscillatory timing preserves coherence across regions. Sleep, therefore, becomes a dialogue between restoration and simulation, between stillness and activity, alternating in measured sequence, guided by internal clocks older than conscious awareness. As the final REM phases approach morning, imagery may feel more continuous, yet the underlying architecture remains steady, cycles closing gently, preparing the organism for return to wakefulness. And through each transition, the mind continues its quiet integration, recalibrating emotion, stabilizing memory, sustaining physical renewal, moving steadily within the natural cadence of sleep, where biology and consciousness remain inseparably aligned. Beyond the visible cycles of night and day, an internal timing system guides the rhythm of sleep. Deep within the brain, a small cluster of cells functions as a biological clock, coordinating hormonal release, body temperature, alertness, and rest across a repeating 24-hour pattern. This internal clock responds primarily to light. Specialized receptors in the eyes detect changes in brightness, transmitting signals that influence melatonin production. As darkness increases, Sleep-promoting signals rise gradually, aligning physiology with environmental transition. Circadian rhythm does not control sleep alone. It shapes energy fluctuations, digestion, cognitive clarity, and emotional stability. The entire organism follows this oscillation, even when awareness does not consciously track it. Core body temperature shifts predictably across the cycle, reaching its lowest point in the early hours before dawn. This subtle cooling supports deeper stages of sleep, while gradual warming toward morning prepares neural systems for reactivation. Hormonal patterns mirror this rhythm. Cortisol remains low during early night, allowing restorative processes to dominate. Later, levels increase gently, not as stress, but as preparation for wakefulness, coordinating alertness with light exposure. Disruption of this timing can alter sleep architecture. Irregular light patterns, inconsistent schedules, or environmental noise may shift the internal clock slightly. Yet the system continuously attempts to recalibrate, guided by external cues and biological stability. Even individuals separated from natural daylight still display cyclical sleep patterns, demonstrating that the rhythm originates internally, shaped by evolution long before artificial lighting existed. Brainwave progression also aligns with circadian influence. Deeper, slow-wave activity occurs most strongly when internal timing favors restoration. REM phases expand as morning approaches, following predictable proportion within the overall structure. The coordination between circadian rhythm and sleep stages forms a layered system, one regulating timing, the other regulating depth, together creating a structured architecture rather than random rest. As night unfolds, this internal clock maintains steady precision, adjusting chemical gradients, synchronizing neural oscillations, preserving balance across organs and tissues. Sleep becomes not merely a response to fatigue, but participation in a planetary rhythm. Light fading, temperature lowering, hormones shifting, electrical patterns slowing in harmony with rotation of the Earth. And within that quiet alignment, brain and body move together in synchronized cadence, guided by ancient timing mechanisms, carrying awareness through predictable transitions toward deeper cycles of restoration. Steady, structured, and profoundly calm. While sleep follows structured biological rhythm, its absence also produces measurable change. Even mild reduction in sleep duration can subtly alter neural coordination. Attention becomes less stable. Reaction timing slows. Emotional responses grow slightly less regulated. The prefrontal cortex, responsible for planning and decision-making, becomes less efficient under sleep restriction, while deeper emotional centers may become more reactive. This shift reflects imbalance in regulatory networks rather than permanent dysfunction. Memory formation is particularly sensitive to sleep quality. Without adequate slow-wave phases, hippocampal encoding becomes less stable. Newly learned information remains fragile. Integration into long-term storage weakens. Metabolic regulation also shifts when sleep is shortened. Hormones involved in appetite and energy balance fluctuate differently. Signaling patterns that influence hunger and satiety adjust subtly, demonstrating the interconnected nature of rest and bodily equilibrium. Immune signaling becomes slightly less coordinated. Inflammatory markers may increase temporarily, reflecting the body's reliance on sleep for cellular maintenance and defense calibration. Yet the system remains adaptive. Even after brief disruption, restorative sleep can gradually re-establish balance. Slow-wave activity may increase in intensity following deprivation, reflecting compensatory biological response. This rebound effect illustrates how deeply sleep is embedded in physiological architecture. The organism prioritizes restoration when given opportunity, recalibrating neural oscillations and hormonal gradients with quiet persistence. Emotional stability often improves after consistent rest. Neural communication between regulatory regions strengthens. Responses to stress soften. Mood variability decreases, demonstrating that sleep is integral to psychological resilience. Attention networks regain synchronization. Working memory stabilizes. Reaction time normalizes. Cognitive clarity returns as oscillatory timing realigns. Across evolutionary history, survival depended upon this cyclical restoration. Organisms that maintained stable sleep-wake rhythm preserved energy, repaired tissue, integrated learning, and regulated social behavior effectively. Sleep therefore functions as foundational maintenance, not optional luxury. Its architecture woven into every system, from synaptic plasticity to immune defense, from metabolic balance to emotional integration. And as night continues its steady passage, the body remains engaged in quiet recalibration. Neural circuits refining themselves, hormonal patterns stabilizing, cells restoring structural integrity. Within this ongoing biological renewal, the mind rests not in absence, but in structured repair, guided by rhythms older than conscious thought, moving patiently through cycles designed for balance, stability, and calm continuity. Throughout waking hours, the brain continuously absorbs information, sensory impressions, conversations, movements, emotions. Each experience leaving subtle traces within neural networks. Yet these traces remain unstable at first, fragile patterns awaiting consolidation. Sleep provides the conditions required for stabilization. During slow-wave phases, coordinated bursts of activity replay fragments of recent experience. Hippocampal circuits briefly reactivate, transmitting compressed signals toward distributed cortical regions, strengthening connections through repetition. This replay does not feel like conscious recall. It unfolds beneath awareness, neural sequences repeating in accelerated form, reinforcing synaptic pathways that were activated during the day, gradually embedding learning into long-term architecture. Procedural memory, the memory of movement and skill, also benefits from sleep cycles. Motor patterns practiced repeatedly during waking hours become smoother after rest. Coordination refines. Efficiency improves without additional rehearsal. Emotional memory undergoes transformation as well. Experiences charged with intensity are revisited in altered neurochemical conditions. Stress-related signaling reduced, allowing memory to remain while emotional reactivity softens. REM sleep contributes uniquely to this integration. Associative networks activate more freely, linking distant concepts, strengthening creative connections, allowing the brain to reorganize information beyond linear structure. Research shows that individuals often demonstrate improved problem-solving ability after sleep, not because new information was added, but because internal networks reorganized quietly, forming connections previously unnoticed. Synaptic homeostasis also occurs during rest. Certain overactive connections reduce in strength slightly, preventing overload, maintaining balance between excitation and inhibition. This recalibration preserves efficiency within dense neural systems. Without this nightly restructuring, learning becomes fragmented. Emotional intensity lingers. Cognitive flexibility narrows. Yet with consistent sleep, clarity stabilizes. Adaptability increases. The brain, therefore, alternates between acquisition and integration, waking for input, sleeping for refinement, each phase dependent upon the other for long-term stability. This oscillation mirrors the broader rhythm of life: expansion and consolidation, activity and restoration, experience and integration, governed not by urgency, but by timing. As sleep deepens through successive cycles, replay continues quietly, memories reorganizing within structured neural timing, experiences woven into durable patterns, preserving identity across days and years. And within that steady repetition, the mind remains active in silence, strengthening what is needed, softening what is not, guided by synchronized waves that carry learning gently into lasting form, sustained by the calm architecture of sleep. Across the quiet hours of the night, emotional systems continue their subtle recalibration. Circuits that responded intensely during the day gradually shift into slower patterns. Neural communication between deeper limbic regions and regulatory cortical areas becomes more balanced. During wakefulness, the amygdala responds rapidly to perceived significance, amplifying signals of urgency or reward. Yet, without restorative sleep, this responsiveness may remain heightened, increasing sensitivity to stress and emotional fluctuation. Sleep introduces a different neurochemical environment. Levels of certain activating neurotransmitters decrease, allowing emotional circuits to replay experiences under calmer internal conditions. Memories remain accessible, but their intensity may soften slightly through repetition within safe neural timing. Functional imaging studies suggest that after sufficient sleep, connectivity between emotional centers and prefrontal regulatory regions improves. This coordination supports measured responses rather than impulsive reaction, allowing reflection to accompany feeling. Dream phases contribute uniquely to this adjustment. Emotional fragments may appear in symbolic form, separated from immediate context, giving the brain opportunity to process affective information without external pressure. Integration unfolds gradually rather than forcefully. Physiological systems reflect this recalibration as well. Heart rate variability increases when sleep is stable, indicating flexibility within autonomic balance. Greater variability corresponds with resilience rather than instability, demonstrating adaptability in response to environmental change. When sleep becomes irregular, Mood variability often increases. Small stressors feel amplified. Attention narrows. Patience shortens. These shifts arise not from weakness, but from temporary imbalance within coordinated networks. Yet the restorative effect of consistent sleep can gradually stabilize emotional tone. Repeated cycles reinforce regulation, reducing excessive reactivity over time. The nervous system learns calm through rhythm. This biological foundation of emotional balance underscores how deeply intertwined psychology and physiology remain. Feeling is not separate from neural timing. It is shaped by oscillation, by coordinated firing patterns rising and falling across networks. As the night continues, slow waves and REM phases alternate in structured sequence, each cycle contributing to emotional integration, memory refinement, and physiological equilibrium. Within this steady architecture, intensity yields to moderation. Urgency softens into stability. The brain continues its silent recalibration beneath awareness. And as synchronization persists through the remaining hours, emotional systems settle further into balanced cadence, guided not by conscious effort, but by the predictable rhythm of sleep, maintaining harmony between thought, feeling, and biological timing. Beyond the quiet recalibration of emotion and memory, sleep supports processes unfolding at cellular depth. Beneath conscious awareness, tissues repair, energy stores stabilize, and microscopic systems restore internal balance. During deeper stages of sleep, growth hormone is released in greater concentration, guiding tissue maintenance and cellular regeneration. Proteins are synthesized. Minor structural damage accumulated during waking movement is corrected, supporting muscular and connective integrity. The immune system also follows rhythmic timing. Certain signaling molecules increase during early night phases, coordinating defense calibration and inflammatory balance. Consistent sleep strengthens this precision, while irregular cycles may slightly disrupt coordination. Metabolic regulation remains closely linked to sleep architecture. Glucose processing efficiency varies depending on rest quality. Hormonal signals influencing appetite and satiety fluctuate in predictable patterns aligned with circadian rhythm. Stability in sleep supports stability in energy balance. Core temperature regulation adjusts throughout the night. Small, predictable reductions in temperature support deeper, slow-wave phases. These shifts are subtle, yet essential to overall physiological timing. Cardiovascular systems respond to sleep depth as well. Blood pressure declines gently during non-REM stages, allowing vessels to rest from daytime demands. This nightly reduction contributes to long-term cardiovascular resilience. Respiratory rhythm remains steady and efficient. Oxygen exchange continues without interruption. Neural centers in the brainstem maintain automatic regulation, demonstrating that sleep alters consciousness, not life-sustaining coordination. Even at microscopic scale, cellular waste clearance increases during sleep. Interstitial spaces in the brain expand slightly, allowing fluid exchange that supports removal of metabolic byproducts accumulated during active cognition. A quiet cleansing process sustained by oscillatory timing. Hormonal balance remains dynamic across cycles. Early night emphasizing restoration. Later phases preparing gradual reactivation. Endocrine coordination aligns seamlessly with neural progression. These biological processes illustrate that sleep extends far beyond mental rest. It is systemic recalibration, operating across organs, tissues, and molecular pathways, all synchronized through predictable rhythm. As cycles repeat across the night, each system receives opportunity for renewal. Restoration distributed evenly through structured stages, preventing overload and maintaining equilibrium. Within this deeply ordered architecture, the body repairs without instruction, recalibrates without urgency, guided by oscillations refined through evolutionary continuity. And as synchronized waves continue rising and falling, physiological systems remain aligned in quiet precision, sustaining stability, supporting resilience, and carrying the organism gently through the steady, restorative cadence of sleep. As the body restores and neural systems recalibrate, consciousness itself undergoes gradual transformation. Wakefulness does not vanish abruptly. It recedes through layered transitions, awareness narrowing, sensory input dimming, internal rhythms becoming more prominent than external signals. In early sleep stages, fragments of thought may still appear, brief imagery, incomplete sentences, soft, drifting impressions without structure. This transitional state reflects shifting dominance between attentional networks and internally generated activity. As depth increases, external responsiveness declines further. The thalamus reduces sensory relay to the cortex, limiting incoming information, creating separation between environment and internal neural processing. The mind turns inward not by decision, but by timing. Slow-wave sleep represents one of the deepest alterations of consciousness. Widespread synchronized oscillations reduce complex awareness. Yet the brain remains active, coordinating restorative functions beneath the surface of perception. REM sleep introduces another distinct state. Vivid internal imagery may arise, narratives unfolding without deliberate control. Yet executive regulation remains reduced. Logical coherence softens. Emotional and associative regions guiding experience more freely. These alternating states demonstrate that consciousness is not singular or fixed. It exists along a continuum, shaped by electrical timing, neurotransmitter balance, and network coordination. Neuroscience suggests that conscious awareness depends upon integration across distributed brain regions. During deep sleep, this integration becomes less globally synchronized. Local networks remain active, but unified awareness decreases. This shifting integration helps explain why awareness feels fluid across sleep stages, from drifting semi-thought to profound stillness, to vivid internal simulation, each state reflecting different patterns of neural coherence. Despite the reduced awareness of external reality, internal processes remain highly organized. Memory replay, emotional recalibration, cellular repair, all continuing with structured precision. Upon waking, reactivation unfolds gradually. sensory systems resume dominance. Integration across cortical networks increases. Consciousness expands outward once again. The oscillation between wakefulness and sleep reveals that consciousness is dynamic, not permanent, dependent upon timing and coordination rather than constant activation. Within this nightly transformation, the mind cycles through varied configurations, each essential to long-term balance, each governed by predictable neural rhythms. And as the remaining cycles continue their steady alternation, awareness drifts further from structured thought, guided by synchronized oscillations, carrying the mind gently between states, within the quiet architecture of sleep. As the night deepens, the perception of time begins to shift. During wakefulness, minutes are measured by movement, by sound, by thought layered upon thought. Yet in sleep, this structure loosens. Duration becomes fluid, untethered from conscious tracking. In early stages of rest, awareness of time may linger faintly, brief impressions forming and dissolving. But as neural oscillations slow, temporal reference fades. The brain no longer anchors experience to sequential markers. Slow-wave sleep is often experienced as timeless, not because time ceases, but because the neural systems responsible for monitoring it become less integrated. Frontal regions involved in temporal judgment reduce coordinated activity, allowing the sense of passage to dissolve. During REM phases, dreams may unfold with apparent narrative, yet their internal timing rarely matches physical duration. Extended experiences may occur within short biological intervals, illustrating that perceived time depends upon neural structure rather than clock measurement. Circadian rhythm continues its steady progression beneath this altered perception. Hormones fluctuate predictably. Body temperature shifts gradually. Light outside changes, yet internal awareness remains detached from these cues. This separation between biological timing and subjective experience reveals how constructed temporal awareness truly is. It arises from network integration, and when integration shifts, perception shifts with it. Upon waking, continuity resumes. The mind reestablishes sequence, reconstructing narrative from fragmented memory, bridging the gap between sleep and day without effort. The elasticity of time in sleep also contributes to psychological restoration. Without constant measurement, cognitive load decreases, urgency dissolves, allowing neural systems to operate free from evaluative tracking. Even brief naps can alter perceived duration, demonstrating that once oscillatory patterns slow sufficiently, the brain transitions away from structured temporal processing. Across evolutionary history, this nightly suspension of time likely supported deep restoration, removing pressure of constant vigilance, permitting physiological systems to prioritize recovery over orientation. Within the architecture of sleep, time continues externally, yet internally it softens into rhythm rather than count, into oscillation rather than sequence. As cycles move toward their final repetition before morning, circadian signals gently prepare reactivation. Yet within the quiet interior of sleep, duration remains diffuse, unmeasured, guided only by the steady cadence of synchronized waves. And in that softened sense of passing, the mind rests beyond urgency, beyond tracking, held within the calm continuum of biological rhythm, where time becomes gentle, spacious, and quietly unbound. Throughout the waking day, the nervous system constantly evaluates environment, scanning for relevance, adjusting heart rhythm, muscle tone, and attention in response to subtle signals. This vigilance is necessary for interaction and adaptation, yet it requires periodic recalibration. Sleep provides that recalibration through gradual dominance of the parasympathetic system, the branch associated with restoration and internal regulation. As wakefulness recedes, sympathetic activation decreases. Muscle tension softens. Breathing steadies into slower cycles. Cortisol levels, often associated with alertness and stress response, remain lower during early night phases, allowing repair mechanisms to proceed without competing activation. This shift does not eliminate the stress system, it balances it. Heart rate variability often increases during stable sleep, reflecting flexibility within autonomic regulation, rather than rigidity. This variability indicates the nervous system's ability to respond adaptively when needed, while remaining calm in rest. Chronic sleep restriction can gradually alter this balance. Sympathetic activation may remain slightly elevated, recovery incomplete, emotional thresholds lowered. Yet consistent restorative sleep helps re-establish equilibrium across these networks. The hypothalamic pituitary adrenal axis, central to stress response coordination, follows circadian rhythm as well. Nightly cycles modulate its activity, preventing constant activation, preserving sensitivity rather than exhaustion. During deeper stages of sleep, neural communication between regulatory cortical areas and limbic structures stabilizes, reducing excessive threat signaling, promoting measured emotional response the following day. Even breathing patterns contribute to this regulation. Slow, consistent respiration during non-REM phases supports vagal tone, reinforcing parasympathetic influence, aligning cardiovascular and neural timing in coordinated rhythm. Sleep, therefore, functions as nightly reset of physiological vigilance, not by suppressing the stress system entirely, but by restoring proportional response, maintaining readiness without chronic activation. Over time, stable sleep patterns correlate with improved resilience, adaptive stress handling, and emotional steadiness, demonstrating how intimately rest supports psychological stability. The nervous system learns rhythm through repetition, nightly descent into slower oscillation, daily return to wakefulness, each transition reinforcing balance between activation and recovery. Within this oscillating architecture, tension yields to regulation, urgency softens into measured readiness, and biological systems maintain dynamic equilibrium rather than constant alertness. As cycles continue toward morning, parasympathetic dominance gradually eases, alertness preparing to rise. Yet the restorative balance established during sleep remains, supporting calm re-entry into waking life, grounded in the steady rhythm that carried the body through the night. Sleep does not remain identical across a lifetime. Its architecture shifts gradually with age, reflecting developmental timing rather than disorder. In early infancy, Sleep occupies much of each day. Cycles shorter, REM proportion significantly higher, supporting rapid neural growth and synaptic formation. As childhood progresses, slow-wave sleep becomes especially prominent. Deep, restorative phases supporting physical development, immune calibration, and memory stabilization. Circadian rhythm strengthens, aligning more consistently with light and social structure. During adolescence, biological timing shifts slightly later. Melatonin release often occurs at delayed hour, encouraging later sleep onset. This phase difference reflects internal clock variation rather than intentional wakefulness. The rhythm adjusts again in adulthood. In mature adulthood, sleep structure stabilizes. Cycles repeat in predictable proportion. Deep stages gradually reduce in duration compared to earlier years, yet remain functionally essential. REM continues contributing to cognitive and emotional integration. Later in life, sleep may become lighter, awakenings more frequent, slow-wave activity somewhat reduced, yet the need for restoration persists, even as architecture changes subtly. Individual variation also exists independent of age. Genetic factors influence preferred timing. Some individuals naturally align with earlier rhythms, others with later cycles, both reflecting circadian diversity within biological limits. Environmental consistency shapes stability as well. Regular light exposure, consistent timing, and reduced late-night stimulation support synchronized rhythm, while irregular patterns may shift internal timing slightly. Despite variation, the fundamental oscillation remains constant. Cycles of non-REM and REM repeating in structured cadence, restorative processes unfolding regardless of subjective awareness. Short-term fluctuations occur naturally, occasional late nights or altered schedules, yet the internal clock continuously recalibrates when given stable cues, seeking alignment with environmental timing. Across lifespan and individuality, sleep remains adaptive rather than rigid, its structure shaped by developmental stage, genetics, and environmental context, yet always serving foundational physiological restoration. This flexibility demonstrates resilience within biological design. The system adjusts proportion, but maintains core oscillatory framework, preserving neural integration, emotional balance, and metabolic stability. As night continues, these cycles repeat without conscious guidance, shaped by age, timing, and internal clock precision, yet unified by the same underlying rhythm that sustains every human organism. Within that shared cadence, variation becomes natural expression rather than disruption, and sleep continues its steady progression, structured, adaptive, and quietly essential across every stage of life. As the night advances toward its later cycles, dream activity often becomes more sustained, imagery unfolding with greater continuity, though still guided by internal association rather than external logic. The brain constructs experience from memory fragments, emotional tone, and stored sensory impressions. Visual regions activate in coordinated patterns during REM phases, generating landscapes, faces, movement, while motor output remains inhibited, preventing the body from enacting internal scenes. This separation allows vivid simulation without physical consequence. The prefrontal cortex, associated with structured reasoning and self-monitoring, shows reduced activity during dreaming, which may explain the fluid acceptance of unusual transitions, time shifts, and symbolic transformations. internal narrative continues without critical evaluation. Despite the imaginative quality of dreams, they arise from structured neurobiology. Neurotransmitter levels shift predictably. Acetylcholine increases, while certain monoamines remain lower, creating a chemical environment distinct from wakefulness. Memory networks contribute selectively. Fragments of recent experience intertwine with distant memories, forming hybrid scenes, often symbolic rather than literal, reflecting emotional processing more than chronological replay. Some research suggests that dreaming may assist in social simulation, allowing the brain to rehearse interactions within internally generated scenarios, refining emotional interpretation without external exposure. Dream intensity can vary across individuals, influenced by sleep depth, circadian timing, and personal neurochemistry. Yet REM remains a consistent feature of healthy sleep architecture across human populations. Even when dreams are not remembered, the underlying neural integration still occurs. Recall depends on brief awakenings near REM completion, without which imagery dissolves before conscious retrieval. The distinction between dreaming and waking illustrates flexibility of perception. Consciousness constructs reality from neural signaling, and when signaling shifts, experience shifts accordingly. Across successive cycles, REM duration lengthens toward morning, allowing extended periods of internal simulation, while slow-wave stages gradually shorten, maintaining balance between restoration and integration. This alternating architecture reflects evolutionary refinement, preserving both physical repair and cognitive emotional adaptation within a single nightly framework. As dreams unfold silently within these cycles, they contribute quietly to psychological organization, weaving memory, emotion, and imagination into stable structure, even when awareness does not carry them forward into daylight. And through these final extended phases, the brain continues its internal dialogue, shaping narrative without effort, aligning emotional tone with experience, moving steadily within the layered, rhythmic design of sleep. As the final portion of the night unfolds, the architecture of sleep begins its gentle transition toward waking stability. Deep, slow-wave activity gradually decreases in intensity, while lighter non-REM stages and extended REM phases occupy a larger share of the remaining cycles. This shift is not abrupt, it is structured, progressive, and biologically timed. Neural oscillations become slightly faster and less synchronized than during the deepest phases. Cortical regions increase communication. Integration across distributed networks strengthens gradually, preparing awareness for reemergence without sudden activation. Hormonal signals adjust in parallel. Melatonin levels begin their slow decline as environmental light approaches. Cortisol rises carefully in anticipation of alertness, not as stress, but as metabolic readiness. Body temperature increases subtly, supporting cognitive activation. During these late REM phases, dream imagery may become more sustained, sometimes more coherent, reflecting higher cortical engagement. Yet muscular inhibition remains in place, preserving physical stillness even as internal simulation continues. Memory integration processes continue through these final cycles. Associative networks refine connections. Emotional tone stabilizes. Overnight consolidation reaching completion before wakefulness returns. Cardiovascular patterns shift slightly toward daytime rhythm. Blood pressure increases gradually from its lowest nighttime levels. Breathing becomes marginally more variable, signaling transition without disruption. The thalamus resumes fuller sensory relay, preparing cortical regions for incoming external input. Yet this reactivation unfolds in stages rather than instantly. Awareness returns in layers. Circadian rhythm orchestrates this entire progression with precision, aligning hormonal gradients, neural excitability, and metabolic readiness with environmental light cues, ensuring that waking does not feel forced, but timed. Even spontaneous awakening often coincides with lighter sleep phases, demonstrating how precisely these cycles coordinate internal and external alignment. The brain prefers transition when oscillatory state supports rapid integration. Despite this shift toward alertness, the restorative work of the night remains embedded within neural networks. Synaptic recalibration completed, cellular repair executed, emotional systems balanced, immune signaling adjusted. Sleep concludes not with interruption, but with completion, cycles reaching natural boundary before consciousness expands outward again. As morning approaches, awareness begins to gather, thoughts forming more continuously, sensory input reclaiming dominance. Yet beneath this emergence remains the steady imprint of the night's rhythm. Brain and body have moved through structured restoration, oscillation after oscillation, guided by ancient biological timing, preparing once more for engagement with the world. And in this final quiet stretch before full wakefulness, the system remains balanced, neither fully asleep nor fully alert, suspended briefly within transition, held gently between darkness and light, completing the calm, cyclical architecture of sleep. As the final cycle approaches completion, the internal rhythm begins its quiet ascent toward wakefulness, not as interruption, but as continuation of the same structured design. Oscillations that once moved slowly in deep synchronized waves now transition into lighter, coordinated patterns. Neurocommunication expands gradually across cortical networks, integration increasing in scope, though still softened by residual calm. The brain prepares for awareness while preserving the balance established through the night. Hormonal gradients shift predictably, melatonin tapering gently, cortisol rising in measured progression, body temperature increasing by subtle degrees, metabolism preparing for outward engagement, each adjustment aligned with circadian precision. REM phases near morning often extend slightly longer, dream imagery flowing more continuously, associative networks active, emotional tone stabilized through repetition, integration reaching its quiet completion before external input resumes dominance. Cardiovascular rhythm follows suit, blood pressure elevating gradually from its nocturnal low, breathing becoming marginally more variable, autonomic balance shifting from restorative dominance toward alert readiness, yet without abrupt acceleration. The sensory systems begin reorienting, the thalamus reopening channels for incoming signals. Cortical responsiveness increasing. Though awareness has not yet fully surfaced, suspended briefly within transition. This delicate threshold between sleep and wake reflects continuity rather than division. The same biological timing guiding both descent and ascent, maintaining coherence across states. Throughout the night, repair has occurred, memory stabilized, emotional systems recalibrated, immune signaling refined, neuroplasticity preserved. Each function executed within structured sequence. Now, the architecture nears completion, cycles having fulfilled their proportion, oscillations having reinforced balance, integration having settled into stable configuration. The organism stands at the quiet boundary between darkness and light. Restoration embedded within neural networks. Readiness forming without urgency. In this suspended moment, the rhythm remains steady, neither fully silent nor fully awake. A calm equilibrium shaped by synchronized waves, guiding the final transition forward. And as the night releases its final layer of stillness, awareness prepares to rise gently, carried by the same ancient biological cadence that governs every descent into rest and every return to the world beyond it. As the night settles into its final extended rhythm, the brain continues working in quiet coordination, though awareness remains distant beneath the surface. Electrical activity maintains structured cadence, rising and falling in organized patterns that preserve long-term stability. Across the cortex, synchronized oscillations help maintain balance between excitation and inhibition, preventing overload while reinforcing essential pathways. This nightly recalibration preserves efficiency, ensuring that neural communication remains precise rather than chaotic. Within deeper brain structures, regulatory centers maintain timing between sleep stages, transitions unfolding without abrupt disruption. Each shift measured, each cycle aligned with circadian guidance, preserving continuity across the entire night. Even metabolic demand shifts gently. Glucose utilization decreases during deeper phases, allowing energy conservation, while specific regions activate during REM, sustaining memory integration and emotional refinement. The balance between these alternating states reflects biological economy, energy redistributed according to function, restoration emphasized early, integration emphasized later, forming a complete system rather than isolated processes. Across repeated nights, this rhythm builds cumulative stability. Consistent sleep reinforces structural integrity. Irregularity may introduce fluctuation, yet the system continuously seeks alignment, guided by internal timing rather than conscious control. Autonomic systems remain harmonized, cardiovascular patterns steady, respiration fluid, immune signaling regulated, demonstrating that sleep coordinates the entire organism, not solely the brain. In this extended late-night phase, oscillations become lighter, yet still organized. Awareness remains softened, sensory input reduced, but neural readiness gradually increasing in anticipation of morning. The thalamus begins subtle preparation for sensory relay. Cortical networks regain broader connectivity, though integration remains incomplete. suspended between rest and awakening. Within this delicate threshold, the organism holds balanced state, restoration largely complete, integration nearly finished, poised quietly before transition. Sleep's architecture has unfolded in full sequence: slow waves, REM phases, hormonal timing, cellular repair, emotional recalibration, all guided by predictable biological design. And as this penultimate rhythm continues its gentle repetition, the system remains calm, stable, synchronized, carried steadily toward the final transition, without urgency, without interruption, sustained by the same ancient cadence that has guided every night before it. As wakefulness slowly returns to the surface of awareness, the transition remains gradual, structured, almost imperceptible. Neural networks that quieted through the night begin coordinating once more in outward direction. Sensory systems reopen their channels. Light filters through closed eyelids. Internal rhythms align with the approaching day. The brain does not switch abruptly from silence to activity. It rises in layers. First, subtle shifts in electrical pattern, then gentle restoration of orientation, memory of place, of identity, of sequence. Integration expands until coherent awareness stabilizes again. Body temperature continues its gradual increase, supporting metabolic readiness. Breathing adjusts slightly. Heart rhythm aligns with mild anticipatory activation. Yet the calm foundation of the night remains intact beneath this change. Sleep has completed its architecture. Slow waves have reinforced structural stability. REM cycles have integrated memory and emotion. Hormonal rhythms have recalibrated timing. Immune and cellular systems have restored internal equilibrium. The oscillation between wake and rest reveals continuity rather than separation, each night reinforcing the biological design that sustains clarity, resilience, and regulation. Not by force, but by repetition. Across the lifespan, this rhythm persists, adaptable yet consistent, shaped by circadian timing, neural synchronization, and chemical balance, maintaining harmony between brain and body through countless cycles. Even when awareness returns, traces of nocturnal recalibration remain present. Emotional tone steadier, cognitive networks refined, physiological systems balanced, restoration embedded within structure. Sleep, therefore, becomes more than a pause. It is an essential phase of ongoing organization, a nightly descent into coordinated restoration, followed by measured return into engagement. And as the cycle concludes once more, the steady rhythm that guided brain and body through darkness continues quietly within, prepared to repeat again with the coming night. Aligned with planetary rotation, governed by internal timing, sustained by synchronized waves. And as the light fades, the silence becomes absolute. Tonight, you have drifted through the mysteries, absorbed the peace, and understood the ancient rhythm of the body and mind. Remember that the rhythm of sleep is always holding you, a constant, silent anchor. Rest now, deeply. Sleep well, and I look forward to guiding you again through the physics of the dark. Good night.